Any questions about quizzes or anything like that in Canvas? Because your first one's coming up due tomorrow, besides the syllabus one. Okay. So you took the syllabus quiz, that should have been put in yesterday, and then there's a one that's coming up tomorrow, and that's over the stuff kind of like off of this worksheet, sections 2.1, 2.2, I'm pretty sure. Okay. You can take it whenever you want. I always recommend, if possible, it's not a bad idea to go ahead and take your first attempt like today. And then if you have any questions, then you can bring those to class tomorrow so that if you're going to retake it before the due date, you'll have a chance to come and ask questions about any of the problems. So it's not a bad idea to try your first attempt maybe one day early, so it gives you a chance to come in and ask questions. All right? So yesterday we were looking at simplifying expressions. So we looked at like terms, we looked at evaluating expressions, which meant, plugging values in. Then the last two parts on that worksheet I had handed out, they had to do with actually forming algebraic expressions. So I gave you a sentence, all right, and the sentence it was like the sum, so it said the sum of what, 9 and 1? Okay. So we want to be able to translate sentences into expressions or equations. And the reason for that is because the equations and the expressions are going to be what are going to help us solve application problems. So if you're reading a story problem, you're doing some sort of application, somehow you're going to have to form those into expressions or equations. So this one has a keyword in it. What does sum mean? Yeah, so this means add or plus, right? And one thing that you can look for is, like, if you have a sentence that you're trying to turn into an expression, there's going to be something that tells you what the operator is going to be. So here the operator is going to be addition. And then the sign itself, you look for this sign and. The and helps you know where to put the expression. Now this one's not too hard because you just say the sum of 9 and 1. And so that's just going to be what? 9 plus 1, which, would simplify to 10. So this would be, that would be the expression, but you could simplify it as well. Yeah? All right. Then, now, sometimes subtraction can be a little tricky. You have to be really careful about the order. So the one I gave you said 3 less than x. That was the next one. So less than, that's telling us that we're probably going to do what? Yeah. So there's definitely going to be some subtraction involved. Now the question is this 3 minus x or x minus 3? X minus 3. Yeah, it's x minus 3 because it's 3 less than x. So what that means is the 3 is being taken away from the x. Okay. Now, is that the same as or not as 3 minus x? Are these the same values, x minus 3 and 3 minus x? Yeah, that would be x less than 3. My question is, are they the same? Are those equivalent? No. Is 3 minus x the same as x minus 3? How do you know? How do you know they're not the same? Well, yeah, so you could try a value, though. So, like, you could pick a value. See, because, like, for example, if you actually plugged in, like, let's say if we actually plugged in, say, something easy, like 0, right? 0 minus 3 goes negative, and we'll deal with negative numbers later. But 3 minus 0 stays positive, right? So, this is something we'll talk about more later, but in subtraction, you can't switch the order, right? The order actually matters a lot because they're different expressions. Whereas if you had like addition, though, what about addition? So what about x plus 3 versus 3 plus x?
No matter which way you put it, it's going to equal the same number.
Yeah. So addition, right? Then you can switch the order, but subtraction, you have to be more careful. So it's really important when you're reading an expression and trying to turn it into like a subtraction statement, you have to get the order right because they are very different. Whereas addition, it doesn't matter. We could have wrote that as 1 plus 9 and be the exact same. So, all right. So then the next one we have down there was a product. So it said the product of 6 and y. And what does product mean? Yeah, that's multiplication. And then, of course, I told you like the and kind of tells you where to do that. So how would you write this? This is 6. There's a bunch of ways to write multiplication, right? The dot signifies multiplication. You could write it just 6y. You don't need a sign in between. So if you have a number and a variable next to each other and there's no sign, then it's implied that it's multiplication. Parentheses can also help denote multiplication. You'll see that sometimes. And you will, technically you could write it as 6 times y, but we typically get away from this notation because a lot of times x is used as a variable, so we don't usually use it as a sign for multiplication, just so it doesn't get confusing. So normally those are like the 3 most common ways you'll see multiplication written. All right? So product means multiplication. And then the last one, I'll go back to black. The quotient. What does quotient mean? Yeah, so the quotient of y and 3. Now, this is another one of those where the order really matters. And so when you're trying to translate an expression into a sentence into an expression, you want to follow the order of the sentence. So if this is quotient of y and 3, then how would you write that?
Y divided by 3.
Yeah, y divided by 3. Yeah. Is there another way you could write that?
Like a fraction?
Yeah. So fractions are another way to denote division, right? So y over 3 is equivalent to y divided by 3. And so, sometimes you'll see division written this way, but more often than not, because we'll start dealing more with fractions later on, you'll see division written as a fraction. And actually, the division sign actually is a fraction. It's like a fraction with like blank in the numerator and denominator. But they mean the same thing. Okay. Now, this is another one of those, though, where these are not the same thing, right? So y divided by 3 is not the same as 3 divided by y. So those will give you 2 different values. So that's why it's important to read it left to right. But whereas like multiplication, though, what about those? Are those the same? Yeah, those are the same. Okay. So in multiplication, like addition, you can switch the order. Doesn't really matter. But for subtraction and division, it's really important that you do it in the same order. Because when you flip them, it's not necessarily going to give you the same value. So, all right? Questions about any of those? All right, so one of the things we'll do throughout the quarter is we'll take sentences like this or things out of problems, and we'll want to translate them into expressions or equations. These were all expressions, though. We didn't get into equations. We're going to talk more about that today. All right, so then the last one that I've given you, right, it says that the number of girls is 4 less than the number of boys. And I wanted you to give me an expression that represented the number of girls as a function of the boys, where B would represent the number of boys. So then what would it be? The number of girls is? 4 less than? And then number of boys we're going to put in for B. So 4 less than B, how do you write that?
B minus 4.
Yeah, it's going to be this way, right? This is a subtraction, so it's important to do it the right way. It's 4 less than, so you're taking away 4. What are you taking away 4 from? The number of boys, which is B. So that would be the expression. B minus 4 is the way you would write that. That would explain that one. Okay? All right. So far, so good? Everybody happy? All right. So then today, what I want to do is, if we're getting, so that was the yesterday's one. I labeled it on the thing, but today we'll get into section 2.3. Section 2.3 is all about now looking at equations. All right. So this course is not. There's kind of a pattern in that, there's expressions, there's equations, and there's applications of equations. And then what we're going to work our way through is that, you can you can look at expressions, equations, and applications for different types of numbers, because there's positive numbers, there's negative numbers, there's fractions, there's decimals, there's percentages, stuff like that. And so we're going to start all with whole numbers, just positive numbers in Chapter 2. Then in Chapter 3, we'll start working with negative numbers, and then we'll just work our way up until we have all of the different types of numbers that we're comfortable working with. So we're going to look at equations. What makes an equation an equation? We talked about it yesterday.
Equal sign.
Yeah, I have the equal sign in there, right? So, like, I'll give you an example, right? So if we had an equation, say, like, I don't know, x plus 26 equals, say, 30, right? Because it has an equal sign, it's an equation, and like I mentioned yesterday, what's true about equations, or what can we find for equations?
The variable only has one number.
Yeah, there's only one possible number that can make this equation true. Now, you could probably look at this one. It's pretty straightforward. What's the answer to this one?
4.
Yeah, it looks like probably, right, x has to be 4. Okay, so this would be what we would call the solution. Okay, and the solutions are, it's the value that makes the equation true. Okay, so that's what we're talking about in a solution. There should be some value that makes the equation true, and what we mean by making the equation true is it means that the two sides are the same value. Okay? And so you can see as x equals 4. That one's not too hard to figure out. Now, that's the sort of a guess and check method, which is totally fine. It's not like that's the wrong way to do it. But what's, for those of you who kind of maybe remember how to solve equations, what's another way that we could solve this equation if I was presented with an equation like that without guessing and checking? How could I solve for this? How would I know what that x would be if I wanted to solve this?
Minus 26 on both sides.
Yeah, so when you see an equation, you can solve an equation. Your goal in solving equations is just to isolate the variables. So just get that letter all by itself. And the thing about equations is because for equations are like a scale, right? You're trying to keep the scale balanced. You want them both to have the same value. So you can do whatever you want to one side of an equation as long as you do the exact same thing to the other side of the equation. So when you see an equation like this, you say over here, okay, well, I have my x variable. I want it by itself because that's how that's essentially what algebra is. You know, algebra is just a fancy way of saying that you've got equations with variables in them, and you're trying to isolate those variables. You're trying to get them alone in the equation. So then you just look at, okay, well, what's keeping over here? What's there that I don't want? I want my x alone, so what's there that I don't want there? Well, there's a plus 26. Well, how do you get rid of plus 26? You just take it away. And in a scale, you can take as much as you want off of one side of the scale as long as you take the same amount off the other scale. So we can take away 26 from the left side as long as we take away 26 from the right-hand side. Okay. So then what happens is on the left-hand side, you know, those values cancel out. 26 and minus 26, those cancel out to 0, so you're just left with your variable. Over here, what's 30 minus 26? Well, it's 4. And so that's the solution. But we already knew that was the solution in this case. So if the equation is not that complicated, you could probably just solve it, you know, by yourself, just by looking at it. But it's good to start practicing the process of solving equations with simpler equations so that you kind of get the process down. Because then as the equations get more complicated, it's harder to guess and check. Okay. All right. This is called, well, there's a formal name for it. You can do the same for subtraction. So like, let's say I had the equation, say a minus 15 equals 31. Something like that, right? So again, if I'm trying to solve this equation, you could guess and check and get the answer probably pretty quick. Looks like it's probably going to have to be, what, 46? Okay? But if you're going to solve it algebraically, right, our goal is okay, I got this variable over here. I want to get it by itself. So what do? Well, there's a minus 15 there. I don't want that there anymore, so how do you get rid of it? Yeah, how do you undo minus 15? You just do the opposite operation, right? So I'll add 15 to the left-hand side, and I can do that as long as I add 15 to the other side, and then those will cancel on the left-hand side, and so you just have to add 31 and 15. Okay? And then what does that come out to be? Well, it's 46, and that would be your solution. Yeah? The nice thing about equations is you can always go back and check to make sure they're true. So you can take that solution and go back to the very top line and plug it in. Well, what's 46 minus 15? It's 31. Perfect. That's how you know you got the right answer. All right? What do you think? Not too bad? Not too bad. All right? I'm guessing you guys have probably seen equation solving at least at some point in your life, probably multiple times. All right, I got some practice here for you to do as well. Okay, the key is basically you look for your variable, figure out what's over there with it that you don't want, and then do the opposite operation to get rid of it. Okay. We may end up, I'd also like you to do sort of the translating. So let's say that, how about 6 less than a number is 23. And I want you to find the number. Okay. So, this right here, this sentence right here, this can be translated. Now this one is actually more than an expression, it's actually an equation, and there's a key word in there that tells me that it's going to be equation. Does anybody know what the key word is? Yeah, it's the is right here. So in math, when you see an is inside of a sentence, that's almost guaranteed or almost always going to translate into an equal sign because it's telling you that something is the same as something else. So that's telling me that I'm going to drop an equal sign in this. So if we were to translate this, okay, you have 6 less than a number. How do you write that? So 6 less means you're taking away 6 from... Yeah, so you just give it a variable. You get to choose. If you like n for number, go for n, right? Then what happens? Yeah, it is 23. That's telling you to set it equal to 23. So you translate the sentence into the equation first, then you can use algebra to solve for the solution. So in this case, I got n minus 6. What's over here I don't like? The minus 6. Well, how do you get rid of a minus 6? You just do the opposite operation. I'm just going to add 6 to that side, which is totally kosher as long as you do it to both sides. So they'll cancel over there, and you'll have n equals 29. All right? So, what do you think? Questions? That? Seems okay? Okay, so then today I got some practice problems here. So I'm going to go ahead and pass these out, and then I'll go over the solutions here. I think you'll have time to finish it, but I'll go over the solutions here probably at the end, the last 10 minutes or so. So give these a shot. It might not take you very long. Okay. And again, these worksheets that I hand out in class, I don't collect them. I don't grade them. They're just for your own studying, preparing for the quizzes, preparing for the exams. And as you're working on them, as always, feel free to work together in groups or in pairs, or you can ask me questions as you're working through too, if you have any questions. All right, so if you didn't get a chance to finish them all, that's okay. But just since I know a lot of people have gotten through them, I'm going to go ahead and make sure that you guys have the solutions for this before we go today. The first one's kind of different because the x it's actually minus x. But that one was sort of just an introduction. You could figure out what this has to be, right? Because what would the answer here have to be? What's the answer got to be to that one?
11.
It's got to be 11, right? Because 14 minus 11 is what gets you 3. If you were going to solve that one algebraically, like if you actually wanted to go through the steps, what would you do? How did you guys solve that one? Did you guess and check on that one? Or what did you find? On the very first one up at the top? Did anybody do it without guessing and checking? Did anybody actually do the algebraic steps?
Well, I substituted 12 for x, and then solved it, and it was wrong.
Yeah, you can sub in 12 first, and you can see 12's wrong, but it's pretty close, so you can just try 11. So guess and check is a legitimate strategy. This one's weird, though, because like you have the 14 minus x, so it's like, well, what happens if you take away 14? Then that's when you get into like negative numbers, and you get like negative x equals negative 11. We'll get into negative numbers more in the next chapter, but essentially what happens here is, you know, if the negative x is equal to negative 11, you could actually like think of like multiplying both sides by negative 1 or something, or divided by negative 1, and that's going to flip the sign, which we'll talk more about later. But the guess and check is always, you know, an option, and that one would be 11. The other ones, though, were a little more straightforward. So in the next step, you had x plus 17 equals 33. So how do you solve that one? So plus 17, what do you got to do?
Subtract.
Yeah. You take that 17 away from both sides because you're trying to get rid of it on the left-hand side. So you just be left with x equals, and whatever 33 minus 17 comes out to be, what's that, 16? 16 for that one. Okay? And a lot of times, when like I said, I think I mentioned yesterday, when I go through these solutions, I'll go through them kind of quick, but if you have any questions, please stop me and let me know if you want to revisit any steps. If you have this one, you got a minus 7, how do you get rid of it? Yeah, you do the opposite operation, so I'd add 7 to both sides. So the 7s over there will cancel. You'll just be left with an x on the left-hand side. 24 plus 7 would be 31. Yeah? Okay. Then going down, just some more practice here. If you have an x minus 8 equals 26, how are you going to get rid of that minus 8 that you don't want over there? We would add 8. We're always doing the opposite operation to get rid of the whatever, you know, is trapped next to the x. And then so we'd be left with x equals, well, 26 plus 8. What's that? 34. Okay. Then we got the next one. What was it? S plus 67 equals 89. Well, you got a plus 67. How do you get rid of it? Subtraction. Always the opposite operation, right? So then S would be left over here. 89 minus 67, what's that? 22? Yeah. All right. It doesn't matter which side the variable is on. The strategy is going to still be the same. So I have this C over on the right-hand side. I want to get it by itself. So I really don't want that plus 321 over there. So what should we do? Yeah, we'll take away 321 from both sides. And then if you do 415 minus 321, 90 something? 94. 94? Yeah. Okay. So far so good? All right. Here you got y minus 3 equals 15. How do you get rid of that minus 3? Opposite operation. Plus 3. Looks like the answer would be 18. Perfect. Then we got what? T minus 33 equals 26. The variable doesn't matter, right? The strategy is always the same. Get the variable by itself. How do you get rid of that minus 33? Opposite operation is addition, so we add to knock it out, and you got T equals 59 there, I think. All right. And then again, doesn't really matter if the variable is on the other side. We're still just trying to get it alone. So I want to get rid of that minus 168 on the right-hand side. So what do? Add 168 to both sides. So it knocks it out over there. And then you got 205 plus 168. What's that? 373 would be your answer for that one. So what questions do you have on any of those? Feel pretty comfortable with that? Okay. So sometimes it gets a little trickier when you're trying to translate the sentences and equations, just because if you translate it wrong, then you can get the wrong answer. So for the ones at the bottom, where I see it says 5 more than a number Q is 21. Okay? So 5 more than a number, oh, it's a P, yeah, not a Q, I don't know, I'm just making stuff up. but it's all good. All right. So then, how do you turn that into equation? 5 more. What is that? Addition. 5 more than what? P is, that means, yeah, is 21. Okay. So 5 more than a number is 21. So then, how do you solve this one? You got the plus 5 over there next to P. You want to get rid of it. What do? Minus 5 minus 5. So you're just left with P equals 16. All right? Any questions on that one? All right. Then the last one, subtraction is a little more, you just have to be a little more careful. So it says 18 less than a number W is 46. So 18 less than, that means what are you doing? You're taking away 18 from what? From the number W. And then what do we set it equal to? 46. Okay. And then you got the W minus 18 equals 46. How do you get rid of the minus 18? You don't want that there. So what do? You just add 18 to both sides. Those are gone. And then you're just left with W equals, what's that, 64. So, what do you say? Not too bad? Excellent. So, I don't think most of the stuff in Chapter 2 is not super challenging. It's kind of just reviewing the basics of working with numbers and solving equations. Then in the next chapter, we'll get into some negatives. So if it seems really easy, then I would say just enjoy it while it's easy. And then go ahead and take a crack at the first quiz tonight if you feel like you're ready for that. That's just 2.1 and 2.2, I believe. I think. I could check it, but is that what it is? Just 2.1 and 2.2? Oh, no, it's 2.1 and 2.3. So it does include the stuff that we went through today. So there will be some basic equations on there as well. But, yeah, I would definitely log on and try and give that a shot tonight once you feel ready. And then write down any questions you have if there's any ones that gave you trouble. And then you can come back tomorrow and ask questions. We'll go over those. And then we'll jump into the next couple sections tomorrow. Okay? So I'll see you then.